Alright guys, so binomial theorem in A2 is an expansion of our AS knowledge. First of all, the fact that binomial theorem is an expression with two terms and a power remains unchanged, and the formula also remains unchanged. But binomial theorem can be divided into two categories. That is, the first category is with powers that with a power that is a positive integer whole number. So we covered this in AS level. Let's make this a bit smaller. And the second category of binomial theorem is with a power that is a fraction or is negative. And this is what we are going to cover in A2. So let's start with AS revision first and recap some facts. So let's say I have example 1 plus x 5, and yeah, so let's expand this. So I have phi c0, phi c1, phi c2, phi c3, phi c4, phi c5, and then make these brackets, make one more bracket in each line. This is the easiest method to solve by. Write ones here, and then write x's here, and then phi minus 0, phi minus 1, phi minus 2, phi minus 3, phi minus 4, phi minus, and here I'll have phi 0, 1, 2, 3, 4. Yeah. So this is phi minus. After solving all these lines, let's solve these one by one. So I have 1 multiplied by 1 multiplied by 1. In line 2 I have phi into 1 into x. Then I have 10 into 1 into x squared. 10 into 1 into x cubed. Phi into 1 into x4. 1 into 1 into x power 5. My expansion would look something like 1 plus phi x plus 10x squared plus 10x cubed phi x to the power 4 and x to the power 5. And this is my expansion. Let's keep this here. And my answer would look like 1 plus phi x plus 10x squared plus 10x cubed plus phi x to the power 4 and x to the power. Now we'll take one more example. Let's take something like where x is in the first place. So how about I take x plus 1 to the power. So in this case, first of all, let's write 6c0, 6c1, 6c2, 6c3, 6c4, 6c5, 6c6. Make brackets. X will go here. So x, 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 x. Then make another bracket. or rather brackets, write 1 here, 1 and here I'll have we count backwards in the first, let's say, column. So 6, 5, and 6 minus 2, 4, 6 minus 3, 3, 6 minus 4, 2, 1, 0. And then we have 0, 1, 2, 3, 4, 5, 6. R, R. So I'll solve each of these lines. So I'll have a 1 here, 6, 15, 20. You can also solve simultaneously with me using a calculator and just confirm the values. So multiply signs, another multiply sign is equals to signs. So it's like an established system. If you follow it, you will hardly make any mistakes. X 5, x 4, x cube, x square, x 1. And here I have 1, 1. 1 to any power remains 1. So after expanding each of these lines, I'll have x to the power 6 here, 6x 5 here, 5x fourth power here, 20x cubed, 15x square, 6x and 1 here. Expansion of x plus 1 to the whole power of 6 would look something like this. Just a second. 20x cubed plus 5x square, 6x plus 1. Alright. And now, let's recap a few points. Let's write this as a note. So the expansion of x minus 3, which I have already done, would would look something like this: x square minus 6x plus 9. In this case, we have a middle term 6x. Similarly, the expansion of 4x cubed, which I have already done, would look something like this: minus 64. In this case, we do not have a middle term. Then let's take x 2 minus x to the power 4. So its expansion will look something like this. So in this case, do I have a middle term? Yes, I do. Then let's take one more expansion like 1 plus x to the power 5. So its expansion will look something like this. I am expecting to get 6 terms, by the way. 10x cubed plus 5x to the power 4 and 5x5. Since I have 6 terms here, I don't have a middle term yet again. Now I want you all to note a few facts. That is, the middle term only exists when the power is odd, or wait, is even rather. Like in this case, we had a power 2, so we had 3 terms. Since we had an odd number of terms, we had a middle term. In this case, we had an even power yet again. Thus, we had 5 terms An odd number of terms means that we will have a middle term. And one more fact, the number of terms in an expansion is always one greater than the power. You can correlate these points with these expansions too. Then I have that whenever, or rather thus, in order, I write this in red, thus, in order to find a particular term in a binomial expansion, like you may be asked to find any random term like the first term, second term, and in such a case, there is no need to expand completely. Why so? Because instead, the value of r for which you need to work out is the value of r would be is 1 less than the required term. So this is a very important point. Like let's just say in this case I were to find, let's say, the fourth term. That in this case would be 1, 2, 3, 4. This is the fourth term. The value of r would be, the value of r should be r is equals to 4 minus 1 is equals to 3. In this case, the value of r is 3 here. So if I were to take the value of r as 3 and just work out this line, I get the fourth term. It's this simple. Let's take two more examples for this point. Let's just say I have something like x minus 1 power 8 and I am asked to find the 8th term. So I don't have to expand this completely since I'm only asked to find one term. The value of r would be 1 less than the required term. I made a mistake. Or wait, it's 6th term here. So the value of r is 1 less than the required term. So it's 6 minus 1 is equals to 5. Thus, I'll write the expansion as 8c5 x8 minus 5 and minus 1 5. So 56 is 8c5 x cubed minus 1 since it's an odd power. So minus 56 x cubed is my answer. Similarly, I can be asked to find 2x minus 3 to the power 5. And I'm asked to find the fifth term. I'll apply the same concept. The first step is the value of r. Finding the value of r, that is 1 less than the required term. It turns out to be 4. Then I have to find the fifth term. I'll expand something like this. I have the value of r. So 5 minus 4 for the first term. And then for minus 3 I have 4. So it turns out to be 5 into 2x into 81. And the fifth term turns out to be 810. Now I also talked about the middle term here. Whenever we had the power as an even number, a middle term existed because the number of terms were odd. The number of terms is always one greater than the power. Thus, we can establish another fact. That is, the middle term only exists when the power is even. And another point is that and obviously when the power is odd, there is no middle term. And in order to find the middle term, in order to find a middle term, the value of r is given by r is equals to n, that is the power over 2. This is also important. So for this, let's take another example, or rather a few more. That is, let's have x plus 10 to the whole, or x plus 1 to the whole power 10. And we are asked to find the middle term. So in this case, the value of r would be 10 to the power. In this case, the value of r would be the half of 10, and it turns out to be 5. Then the second step is expansion and finding the middle term. So 10 minus 5 and 1 to the power r. Expanding this would give me, I'll expand the whole thing in my calculator, so I have 252 x power 5. Now, the same step is applied for whatever you have in the bracket. The sequence of steps will remain unchanged. Let's just say I have x in the second place. The sequence of steps would even remain the same then. Let's take an example. 3 plus x to the power 6. I'm asked to find the middle term. So the value of r would be half the value of the power. It turns out to be 3. And the expansion would look something like this. 6 minus 3 and x to the power 3. So this equals 20 into 27 into x cubed. And the answer turns out to be 540 x cubed. Oops, this is my final. And 540 x cubed is the middle term. With this, we wrap up this class, and this is revision of AS level essentially. And we still haven't started the A2 part, which we still have to. And for that, I'll attach a few more